Salutations and greetings I bid to everyone. We are from Alam Shah Science School, Kuala Lumpur, Malaysia. We will be presenting to you our science project, Hevea Brasiliensis seeder. As you can see, the workers are planting the Hevea Brasiliensis seed because there is no machine or tractor that could help them planting it. This process requires a lot of energy and cost. From the slide before, the problem is the rubber seed need to be planted manually because the nursery process needs to be done delicately for its growth. The seeds need to be planted by the dorsal on top and ventral at the bottom. Our objectives for the project are to develop an automatic rubber seed planter, integrate the camera vision with the robotic arm, and to construct a robotic arm that is able to lift, rotate and place the seed for germination. As the slide shows, this is the diagram for our robotic arm model that will be used as the automatic seeder. Its specs are Arduino Uno as the microcontroller. For the actuator of the robotic arm, we use servo motors SMS 8166M, Tower Pro MG995 and SG90, powered with 7.4 volt lithium polymer battery. The maximum distance this robotic arm can reach is 53 centimeters. Here are some pictures from different perspectives. It is also equipped with an Android smartphone camera that connected to a computer on its grabber. After all that, I will now tell you the process of this robotic arm. Firstly, image will be captured and transferred to a computer via wireless network. Then the image will be processed by MATLAB to identify the surface of the seed, whether it's ventral on top or dorsal on top. Now, the robotic arm will begin its work by picking out seed into the nursery poly bag. If necessary, the grabber will be rotated by 180 degrees to acquire the appropriate orientation of the seed. Rubber seed will then be placed in the nursery poly bag delicately, and after it's done, it will return to its initial position and ready to repeat the same process for other seeds. That's all from me. I will be now passing the pleasure to present our project to my friend here.
Thank you, Hakim, for passing on the slides to me. Now, as we can see, we have tested Hevea Brasiliensis seeder according to the instructions given by Amir Hakim and acquired this result. Out of 20 attempts, Hevea Brasiliensis seeder managed to place the seed correctly according to position 18 out of 20 attempts, making it having an accuracy of 90%. And making Hevea Brasiliensis seeder a very reliable. Now, on to the next slide. This slide shows the accuracy in which Hevea Brasiliensis seeder is now placed with the ventral position of the seed at the bottom. Just now, and on the slide before, it was placed at the dorsal part of the seed. Okay, so moving on to the slide. This is now displaying the proof of our experimentation. And as you can see here, we have different type settings and speed for each program for Hevea Brasiliensis seeder, which is we have determined 50%, 80%, and why? This is because we noticed that 50% always brings forth the perfect result. It is the most optimum speed, however, is this a little too slow, having it working on around 20 seconds per seed, and we wanted to find the optimal speed for Hevea Brasiliensis seeder. Therefore, we tried it with the maximum speed, which is 100%, and unsurprisingly, it quite failed since the seed have a drastic accuracy of 50% only, and it is totally inaccurate. Therefore, we need to find a range between 50% and 100% to find the most optimal speed for Hevea Brasiliensis seeder. So after the experimentation, we have found out that 80% is the most optimal speed for Hevea Brasiliensis seeder. Why? This is because even though at a high speed, which is around 10 seconds per seed, it also can achieve an accuracy of 90% per seed planting. Therefore, not to waste time, which is because it is under 10 seconds only, and also it has been our problem solving method to avoid mistake. Now, after the slides, we can see we have came up with the hypothesis that if the speed increases, the accuracy decreases, or basically the accuracy is inversely proportional to the speed. So as you can see in the graph, the maximum point of median in between 50% and 100% is by far 80% speed achieving 90% accuracy. Why don't we pick the 50% in the first place? Because it quite takes some time, which is just the redundantment of what the problem that we are trying to avoid. And after that, we have also to plant a lot of trees, and this is somewhat a problem solving method to solve. Now, allow me to elaborate on the feasibility on our project, or Hevea Brasiliensis, the robot. Not only does it not require a human operation, its precise accuracy and its speed, it also exploits its components in order to make it more functional if any error would occur. So for example, if there is a bumpy road in the land, or for example, if there is a rain and and it will affect the movement of the robot. By now, we have successfully exploited the principles of freedom, making the robot can move in 8 differential positions, which is up, down, backwards, forward, left, right, yaw, roll, yaw, and pitch. Therefore, this wide accessibility is needed so that out of ordinary problems that we wouldn't expect would occur, such as bumpy grounds, can be settled in a breeze. So, as the conclusion of this project, we hope that our project can bring forth many more technologies to be elaborated and to be sufficed in this new future of technology. This may be hard, but to achieve a new modern era of humanity, we need to lessen our labor, lessen our pain in order to achieve a truly modernized era. Therefore, this marks the end of our project, Hevea Brasiliensis. Thank you very much for listening.